Joule-Thomson expansion. So the Joule concept of Joule-Thomson expansion, in a perfectly insulated wall, a gas is expanded, that is throttling. We all know what is throttling. It is a sudden decrease of pressure. The expanded and the curve is plotted of your P versus T. Of your P versus T, the curve is plotted. The curve is obtained in the form of a parabola at a certain point. Okay. So the curve is shown here. This is your curve which is plotted with temperature versus your pressure curve. And these are your these are called the isentropic curves. Okay, these lines are called your isentropic curves. Here the cooling occurs and here your heating occurs. This is the inversion point, or when joining all the maximas, you get this maximum inversion temperature. So all the maximas are joined to get this inversion curve. So this is the basic graph which is obtained in this Joule-Thomson expansion. And you also have these inversion temperatures at the maximas. So this is the basic equation of Joule-Thomson coefficient. This is the Joule-Thomson coefficient, mu Jt. It is known as your Joule-Thomson coefficient. Joule-Thomson coefficient. And this is your partial derivative of temperature with respect to pressure at constant enthalpy. At constant enthalpy, the partial derivative of temperature and pressure is equal to your that is equal to your Joule-Thomson coefficient. Then after that, when the Joule-Thomson coefficient is equal to 0, then the temperature is constant and it is called your inversion temperature. When mu is 0, then temperature is constant. There is no variation of temperature with pressure. So when mu is greater than 0, then the temperature is decreasing. And if the coefficient, Joule-Thomson coefficient is greater than 0, then the temperature increases. Increase or decrease of temperature, it depends on the type of fluid being used. Okay, so there is first increase of temperature, then there is a decrease of temperature. At high enthalpy values, the maxima shift towards the left, towards here it is shifting. And then what is the importance of this Joule-Thomson expansion? It is used to separate a gas from a mixture. Every gas will have different value of the Joule-Thomson coefficient because the variations with temperature and pressure at constant enthalpy are different for every gas. When you have these two equations, the behavior of gas is determined by the equations of state. Now, if equation of the state is known, we can find out del V by del T at constant pressure, and it can be found the variation of volume with respect to temperature at constant pressure can be found. Then we can substitute these values here, and then we can get the variations of temperature and pressure at constant enthalpy. So this is the basic Joule-Thomson coefficient which you need to know for your semester exams or for the basic knowledge of the Joule-Thomson expansion or your Joule-Thomson coefficient.